Welcome back. So in the previous topics we were discussing about the to solve the how to solve the numericals. So based on the required data. See, whenever we are solving all the numericals, so the problem wise it will vary from one problem to other problem based on the given data. See, in the equations or the formulas what we're going to use is similar, but based on the data we need to change that equations and we need to find out the values are the which is the required values we need to find out based on the equations or based on the given data, but we need to rewrite or we need to change that equations according to the data. As I told, if they gives depends upon the data only we can able to change that. So next we're going to see the next problem, what they given and what we need to find out this in this particular problem. A solid circular shaft is required to transmit of 100 kilowatt at an 180 rpm. So what they again is a solid circular shaft is required to transmit a power of 100 kilowatt at an 180 rpm. The permissible shear stress in this shaft is what they given the shear stress in the shaft for this shaft is 60 kilonewton per mm square, and we need to find the suitable diameter of the shaft if the angle of twist should not exceed about 1 degree in a length of 3 meter. So they given the angle of the twist and the length also they given for in a 3 meter. The value of this modulus rigidity, that is G, or what we are going to consider G or SE, is 0.8 into 10 to the power of 5 Newton per mm square, Newton per millimeter square they are given. So what we need to find out in this problem based on the given data is a solid circular shaft is required to transmit 100 kilowatt power at 180 rpm. The permissible shear stress tau they are given. We need to find out the suitable diameter. The suitable diameter for the given conditions or the given data. If the angle of twist should not exceed about 1 degree in a length of 3 meter, the value of modulus of rigidity is 0.8 into 10 to the power of 5 Newton per mm square. So based on the given data, we need to find out the given values. So first we're going to find out the first we'll write down the data, then we'll go for the solution. So power transmitted by the shaft N, what they given is the power transmitted. P, we can write down the notation as P or capital N, that is 100 kilowatt, and the speed of the shaft is 180 rpm revolutions per minute, and the allowable shear stress is 60 kilonewton per mm square. They given, we'll convert that 60 newton per mm square. Then they given angle of twist is 1 degree, that is the given the angle they given in the degree, and the length L is they given the 3 meter, and the modulus of rigidity is 0.8 into 10 to the power of 5 Newton per mm square. So this is the given data. Based on this we need to find out the suitable diameter. So here again they given the length and the angle of twist, so we need to find out the diameter based on the strength criteria, and based on the rigidity criteria we need to find out the diameter, and we need to compare the diameter which is having a higher value. Based on that only we need to select the permissible diameter for this solid circular shaft. Yes, now we go for the solution. So first we're going to find out the, here they have not mentioned any torque, so we need to find out the torque by using this formula. So that is P or N, what is, as I told, the P or N is notations. P N will be equal to 2 pi nt by 60,000. So that is the unit will be kilowatt. Now so already the N value is 100, we know that 100 kilowatt 2 into pi, and N is nothing but 180 rpm. 100 rpm, what they are given the data is nothing but 180 rpm into T. T is unknown, will substitute now, cross multiply, and we'll take the T outside and we'll find out the T now. So what the T value we got is 5.165 Newton meter. So this is what the torque is being transmitted from this particular shaft whenever it is transmitting a power of 100 kilowatt at an 180 rpm. Now this is about the power. Next we need to find out the, first we need to find out the diameter of the shaft based on the strength criterion. So as we told, the standard equation or the standard torsional equation is nothing but T by J will be equal to tau by R will be equal to G theta by L, where J by R it becomes the ZP. ZP is nothing but a polar section modulus. That polar section modulus formula is nothing but pi by 16 into D cube, right? That T by T will be equal to, now already we know the T value, pi by 16 into D cube into tau. Now I'm going to write that Newton meter. What is there? I'm going to write down to the millimeter. 5.305.16 into 10 to the power of 3 will be equal to pi by 16 into d cube into tau. Tau is nothing but what the shear stress they have given is 60 Newton per mm square. Now I'm going to equate, or I'm going to cross multiply this. Now I will take the d cube as an outside. When I'm going to substitute this, pi by 16, 5.35, 5305 into 1.65 into 10 to the power of 3 into 16 divided by pi into 60, which is the values are there. I'm going to substitute. We'll take the d cube outside. Now what the d cube, what the value we're going to get, we're going to cube root that value. Now I'm going to, now we got as a d value as 76.65 mm. Now this diameter is nothing but based on the strength criteria. The diameter of the shaft is nothing, now we got is based on the strength criteria. Now similarly we need to find out based on the rigidity criteria. So now we got the diameter is 76.55 mm based on the strength criteria. Now next what there is diameter of the shaft based on the torsional, based on the strength criteria, that is based on the torsional equation. What is nothing but torsional, based on torsional rigidity. The equation is nothing but T by J will be equal to, either we can able to consider G or C, that is both the indicates the modulus of rigidity only. T by J will be equal to G theta by L. Now T value already we got is nothing but 530.5 into 16 into 10 to the power of 3, and J is nothing but polar moment. See, whenever the J, only the R, when comes J by R, then only it will become the section modulus. Otherwise it will be in the J only, polar moment of inertia. The formula is pi by 32 into d to the power of 4, and now G, that is modulus of rigidity, is given as 0.8 into 10 to the power of 5, and the theta is nothing but 1 into pi by 180 and divided by L is they are given as in 3 meters. So when we are going to convert the 3 meters is, when we convert to the from meter to the millimeter, it will become as in 3000 mm. So that we have written now. Now going to substitute this equation. See, here we have not considered the tau by R, because when we are considering for the torsional rigidity, only the equation what we consider is nothing but T by J will be equal to G theta by L. So similarly 5305.165 into 10 to the power of 3 divided by pi into 32 by pi by 32 into d to the power of 4 will be equal to 0.8 into what the values we have been written. Now I'm going to take this d to the power of 4 outside. What the values we are going to get when we are going to equate and when we are going to substitute this, we are going to substitute that values. Now what the value we got is, by substituting this values for the diameter of the shaft based on this torsional rigidity D will be equal to 103.8 mm, 103.8 mm. What we got based on the torsional rigidity, but based on the strength criteria what we got is 76.65. Now we are going to select the suitable permissible diameter for this shaft, based on the given conditions, to transmit a power of 100 kilowatt at 180 rpm for this solid circular shaft. We are going to consider the diameter. From the given data, diameter of the shaft based on the strength criteria is 76.65. Diameter of the shaft based on the rigidity criteria is, what we got is 103.8 mm. So now we are going to consider the higher value for that diameter of the shaft is 103.8 mm. So whenever we are going to consider the strength and the rigidity criteria, which will be having the higher value, based on that only the higher value only we are going to select for the diameter of that particular shaft. So this is now the diameter of that particular shaft to transmit the so and so power is 103.8 millimeter. Thank you.